Very good morning, friends. In the last presentation, we were dealing with the electrocyclic reactions of the molecules containing 4n electrons and its stereochemistry. In continuation of this, today we are going to discuss about the cyclization of trans-cis-trans 246 octatriene thermally and photochemically along with its stereochemistry. This 246 octatriene are having 6 pi electrons. It is having 4n plus 2 pi electrons, where n is an integer. It has 6 pi electrons. The 2 pi electrons at 2 position, 4 position and 6 position respectively. When it is having 6 pi electrons, it should have 6 way of arrangement of these 2p orbitals. The first 3 are bonding orbitals. These 2p orbitals are arranged in this fashion at psi 1 energy level. Here you see all the 2p orbitals from 2, 3, 4, 5 and 6 and 7 position are all lying in the same phase. In psi 2 position, it is represented like this. The first 3 2p orbitals at 2, 3 and 4 position are in the same phase, and the 4, that is 5th, 6th and 7th position 2p orbitals phases are in the opposite to that of the first 3. In psi 3 level, the first 2p orbitals and the last 2p orbitals are in the same phase, and the in between 2p orbitals are in the opposite phase as that of the p electrons at 2 and 3 and 6 and 7 position. The 3 antibonding orbitals involves psi 5, psi 6 and psi 7. At psi 5 position or psi 4 position, the first 2 orbitals are in the opposite phase. The second 2p orbitals are also in the opposite phase, and the third 2p orbitals are having the opposite are in the opposite phase. In the process, you see that the 2p orbitals at 3 and 4 position are in the same phase, and 2p orbitals at 5 and 6 position are in the same phase. The psi 5 energy level, the 2p orbitals at 2 and 7 position are in the same phase. The 2p orbitals at 3 and 6 position are in the same phase. The orbitals at 4 and 5 position are in the same phase. The psi 6 energy level, all the 2p orbitals are opposite to each other. As we know, when the reaction is induced, electrocyclic reaction is induced thermally, it will undergo disrotation. When the disrotation occurs, that is, the 2p orbitals rotates 90 degrees in the opposite way. One in the clockwise direction, this p orbital in the opposite to that of the first 2p orbital. This rotates 90 degrees clockwise. This rotates 90 degrees anti-clockwise. When this rotates in clockwise and anti-clockwise, the methyl group attached to this p orbital both move in the opposite phase and both come in the same phase. They are in the same plane. That's why they are having cis configuration. When I take trans cis trans 246 octatriene and cyclize it, it gives rise to cis 5,6 dimethyl cyclohexadiene. When I induce the reaction photochemically, the electrons from the psi3 energy level jumps to the next energy level psi4. That's why the HOMO to be considered is psi4. The 2p orbitals at the psi4 energy level are involved in the reaction. When it is induced photochemically, the 2p orbitals at 2 position and 7 position undergo Kohn rotation. Both the p orbitals rotate by 90 degrees in the same direction. Both are rotating in the clockwise, that is Kohn rotation. When a Kohn rotation occurs, the methyl group attached to the at the 7th position moves downwards. The methyl group attached at the 2nd position move upwards. Thus, where the 2 methyl group remains in the opposite planes to each other. That's why it gives rise to trans 5,6 dimethyl cyclohexadiene. When you recall the cyclization of the compounds with 4n electrons, when it is induced thermally, it undergo Kohn rotation and it gives trans derivative. When I take the 2e and 4e, the stereochemistry of the dienes or trans, it gives trans derivative only. But here it is reverse. I'll get cis derivative as it undergo this rotation here, whereas when it is having 4n electrons, it undergo Kohn rotation. It is exactly opposite to that what happens when it is having 4n electrons. Right. Now, summarizing, when I take trans cis trans 246 octatriene, trans means 2e. E means integragon. The groups attached to it are opposite to each other. Z, zusammen. The groups are attached to the or cis to each other or on the same plane. 6e, the groups attached are in the opposite plane. When it is induced thermally, it is the psi3, that is the HOMO, it gives undergo disrotation to give rise to the cis 5,6 dimethyl 1,3 cyclohexadiene. The methyl groups at 5 and 6 position lie in the same plane, that's why they are cis. When it is induced, when I take instead of trans cis trans, if I take trans cis cis 246 octatriene, that is 2e 4z 6z 246 octatriene, then when it is induced thermally, here it is cis, it undergo this rotation and it gives rise to trans derivative, trans 5,6 dimethyl 1,3 cyclohexadiene. Similarly, when I take trans cis trans octatriene, When I induced photochemically, I'll get trans derivative. Similarly, if I take trans cis 246 actotriene, when I induce photochemically, I'll get cis derivative. This is all about the induction of electrocyclic reactions containing 4n plus 2 pi electrons thermally and photochemically, and stereochemistry involved. When I take trans cis trans derivative, I'll get cis. When I thermally trans cis cis octatriene, when it is induced thermally, I'll get trans. And vice versa is true when I induce photochemically. This is all about the electrocyclic reactions with 4n plus 2 pi electrons. In the next presentation, let us deal with the cycloaddition reactions. Till then, have a nice day. Thank you.